Without further ado, I'm going to invite up Dave from Facebook to come give a talk on RACifying.
Thanks, Danny. Hello? Can I up it? Technical difficulties? Okay, I'll just go with this. Okay, thanks for having me here, Danny, and GitHub guys. If I talk like this, is that working? Everybody can hear me? Okay, so the talk that I'm going to do is basically taking non-reactive code, which is pretty much everything that Apple gives us, and how can you basically make reactive versions of them. Obviously, Reactive Cocoa includes a lot of extensions, and this doesn't cover those, so you should feel free to dig into those and see what you can find. But there are cases where you are using a library that maybe is third-party, or maybe it's something we haven't converted. So this is what that talk will be about. So really, RACify is RACsignalify. We're not going to talk about too many other constructs here, especially RACSubject. So where are signals? Signals can be found blocks, any API that has a block, delegates, notifications, anything that has an arrow pointer can be theoretically a signal, target action, KVO, and method overriding. So when you subclass UI view controller, you have to override all those methods. Those can be signals. So how do we bridge the gap? So there's RACsignal defer, which is kind of an easy entry point to having dynamic values, dynamic signal values. Notification center, a lot of stuff gets done with notifications, so there's an API for that. RACsignal for selector, this is probably the workhorse. If you've not used it yet, you'll want to get to know it, and we'll cover it here. RACCreateSignal, this is the basic underlying building blocks of every signal in Reactive Cocoa, and so we'll cover how to use it here. And RACobserve. It doesn't get used too much when using Apple's code. There's not too much stuff that they say, hey, KVO this, that's the best way. There are a few classes that they do though, so. So how do we create signals? It's not that way. There's one way here. This is to create a signal of one value and completes. Create a signal that's an error, or create a signal that just completes and doesn't send anything. RACSubject is another way that people use, bridge Reactive Cocoa code into their Apple APIs, but we don't want to do that. So we'll see how not to do that. So defer. Defer is an easy way to basically have some dynamic value and create a signal out of it. It's a block that just gets called and you have to return a signal. So in this case, this is just a signal that returns a random value. As soon as you subscribe, it'll send a random value and complete right away. But what's going on here is there's some per subscription side effects. So we create a random value and then we send it. So the idea here is defer is a way to group a whole bunch of code that happens on subscription and then calculate a value and return that value. So those were the same, but this one's more explicit about the structure. The same thing can be done with createSignal. So let's take a look at createSignal here. If you haven't seen it, it might look a little bit foreign. This is the class constructor, if you will, and it's a way to create a signal by giving it a block. So in this case, the block always takes a rack subscriber, and I didn't run this through the syntax checker. There should be a closing bracket there. And so the code is the same as before, but here, instead of returning a signal, we get to control that signal manually. We have a rack subscriber that we can send values to. So before, we were just returning RACsignal return, which sends a value and completes. In this case, we're explicitly sending a value and completing. And then this API returns, the block has to return a disposable. Normally the disposable type, if it's necessary, will get set in the block, but for space reasons, I put it down there as a cast on the return type. We'll see how to use rack disposable more in a bit. So you don't have to do anything pretty much inside of create signal. You could theoretically just return nil, and that's the same as rack signal empty. So let's take a look at AF networking. If some of you are familiar with AF networking, you'll recognize something like this. You've got two blocks. One of them is a success block, one of them is a failure block. But this doesn't compose very well, so we want to make a signal API out of it, something that could be repeated or have better error handling. So again, we use create signal. We've got a reference to manager somewhere. That's an AF networking manager. You could compose this into a class of your own. That could be an instance variable or property. So we call the method, and now inside of our success and failure blocks, we're doing what we saw previously. We're sending next with the response, completing, or if there's an error, we're sending error. Now this is missing disposal. So now this get method actually returns an operation, and now we can create a disposable using the disposable with block API and call cancel in it. So that means if for whatever reason we recreate this signal and we don't end up needing it, we can call cancel. Or if we can't want to cancel it midway through, that also works. Sorry, we can call dispose, which will then cancel. Okay, so let's take a look at how we might use RACify core data. So here you have a managed object context. That's a way to sort of keep things thread safe among other things. And it's got a perform block API. So you can't do things like execute fetch request inside, or you're not supposed to do them just generally anywhere. You're supposed to do them inside of these perform block things. But then as a side effect, we have to have this block type attribute on the results. And this is actually asynchronous, so this will get assigned and later it will be available to us. There's also perform block and wait. But this API really sucks because if you want to do other things, you have to either nest them inside the block or you have to just do like a run loop hop or something to wait and see what those results are. So sorry, now we're going to get into a lot of code, I apologize, but to do the same thing, but a signal API, we basically wrap a lot of the same code. You've got the same fetch request, perform request there, but now we're adding in some rack items. So we've got a disposable at the top, and first thing we do inside the block is we check to see if it's been disposed, and if so, we just return. We don't want to do the fetch request anymore. If it hasn't, we move on, and we perform the fetch, which might take up time, but it's on a background queue thanks to the perform block. And then we check the results. Same template pattern there. Send next, send completed, and then send error. Finally, we return that disposal. So you could see something like this being used if you had type like a search field and you wanted to filter your results. You could fire these off where each text update creates one of these signals, and then you just do switch to latest. So that way, as results come in, or as new text gets entered, the old queued requests get canceled. CoreLocation. So now this is a way to RACify delegates. So with delegates, we want to use signal for selector. So here we've created a location manager. This is in some class. You just create your own class, call it whatever you want, and it's going to be the delegate, but we're not going to implement any of the delegate methods. So we set the delegate to self, and then we've got some subscriber count. We'll see where we'll use that in a bit. So again, lots of code here. So the first thing is right at the top, I'm creating a location signal. This is going to be a signal that every time the delegate calls back, did update locations, this signal will send a value. So it's basically a signal version of that delegate method. So here we're using RACsignal for selector. It will create a method for us. So we didn't have to implement this method. It creates it for us. If one already exists, it does some other runtime magic, basically, to hook into that. So once that method gets called, the values get sent along to our signal. So with a delegate, you've got the CoreLocation manager is the first argument. We don't need that. We just want the locations. So reduce each is like map, if you haven't seen it before, and basically allows you to expand the parameters instead of receiving a tuple. Yeah.
What is the signal sent? Like what's the result of doing this?
Right. So this signal, every time that method gets called by the CoreLocation manager, it will send a tuple, a rack tuple. Here, if we didn't do reduce each, we would use a map and we would have rack tuple, and we could just say tuple at 0, tuple at 1. But because we have this convenient reduce each, that allows you to have more sort of clear code, right? So you can see what the values are. I put ID underscore because of space constraints, and also it's kind of typical that if you're not using an argument, you'll put underscore there to say that you don't need it. Because here we don't need the location manager. So that's the first part. That gives us locations. But when you request locations, you can also get errors. And so we want to handle that. So we do another signal for selector, which looks just like the first one, except it did fail with error. So again, reduce each, we pull out our error, but now we've got a little bit more work to do. Right now, once we've done this reduce each, we've got a signal of error values, which is different than a signal that sends an error. A signal that sends error values won't cancel or dispose when that error is sent. But if you send error, you will cancel that signal. So according to the documentation, there's a certain type of error here, error location unknown, that CoreLocation will keep trying. So we have a filter that we want to ignore that because we don't want the signal to cancel unnecessarily. And finally, we use the flatten map operator, which allows you to take a value and basically make a signal out of it. So in this case, we're using rack signal error to lift an error value into an error signal. So the result here is that this error signal, all it can do is send an error or do nothing. Now we combine these two signals using merge. Rack signal merge is basically flatten map for two different signals. So any value, any error sent on either of those two signals get combined together. And we subscribe our subscriber to that signal. So now what we've done is we've created a subscriber, with our subscriber, we've created two different signals and basically bound it to both of them. One of them sends location updates, the other sends errors, or sends an error if possible. When you subscribe, you get a disposable. So we've got a disposable up there, and we're going to use that later in our disposable block. Because you might want to subscribe to this signal in multiple locations, hypothetically, I'm just going to show a way that you can manage in subscriptions side effects that might be starting off work or ending work. So before I showed you there was a subscriber count variable, and basically we're going to increment that atomically and decrement it atomically to keep track of how many subscribers we have. The first time, once we get to 1, we need to start updating location manager, tell the location manager to start updating. Subsequent times, all we're going to do is send the current value on the location manager to the subscriber. Basically a cached value for us on location manager. So finally, we have the disposable block. So again, we were in create signal. We always return a disposable block from create signal. And here, we do two things. First of all, we dispose of the disposable we created up at the top. And the second thing we do is we decrement the subscriber count, and if it's back down to 0, we tell the location manager to stop updating. So now, with this API, you have a signal that you can pass around, anybody can subscribe to it, and starting the updates and ending the updates are handled for you. You don't have to handle that yourself. Also, with errors, you can theoretically try to update something and retry this signal without having to do any imperative checking yourself. You can just use retry with a certain number of counts, or you can use a catch operator or something like that. So we'll go back to AF networking, but only because it's an API that has something that we can use KVO on. So NS progress and NS operations also use KVO, but I didn't think they were as good of a demonstration. So in AF networking, there's something called a reachability manager, and it has a network reachability status. So you might want to show on your UI, pop up an error message or something if you try to do an action that has when you have no network. So this is something that can help you with that. So we observe, which is creating a KVO observation underneath, the network reachability status property on the reachability manager. So that's the first couple lines. Now, all we're doing is just a simple map where we take that status, and if it's reachable via wireless or Wi-Fi, we return yes, otherwise we return no. So now we've got a nice, handy, convenient is-reachable operator that you can use to bind to UI. You might disable a button, or you might show a message, or you might not even attempt to kick off network requests based on this signal. Okay, so notifications. There's a lot of notifications used in Coco, and so we'll take a look at one way in which we can use create a signal out of the notifications instead of manually implementing a whole bunch of methods. So UI application has these 4 notifications, basically to manage when you go from foreground, background, active, inactive. So here, what we're going to accomplish is a signal that tells us when we've fully relaunched. So when you launch, you go will enter foreground, but that's not saying you did enter foreground, that's saying will enter foreground. After that, there's did become active. So what we want is to have a signal that tells us when we've gone from foreground to active. So the first signal, again, we're using merge here, and we have 2 add observer for name signal APIs here. This is how you bridge from NS Notification Center notifications into a signal. So whenever that notification gets posted, these signals will post or send that notification object. Here we're not using any of that. We're not using that, looking at the info dictionary, nothing. All we're doing is mapping it to yes and mapping it to no. So now we have a signal here that when either of these fire, we'll know that we're either in the foreground, or we will enter the foreground, or we did enter background. You could use this for cleanup as you're going into the background as well. Now that we know whether we're in whether we're in the foreground, the next thing we can use is RAC has this nice if then else construct. So if is foreground, so whenever that signal sends yes, then we're going to use the then piece of this method. And here, all we're doing is giving it another signal. So whenever it's foreground, we want this other signal that's did become active. And when it's not foreground, we're just passing in RAC signal empty, which means no values are going to get sent. So now our has launched active signal, what it will do is it will look for that we've entered foreground or will enter foreground as yes, and whenever that's true, it starts passing us the values that from the did become active signal. So that's a good way to have, if you're using MVVM or something, you could theoretically have a view model that doesn't bind to your UI application delegate just by monitoring these notifications. Okay, so that's pretty much it that I wanted to cover. Key points are here that to learn more is take a look at what we have in Reactive Cocoa. There's quite a few extensions there. And basically, signal for selector is your main friend. You won't use the notification stuff as much. You probably won't create signals as much, but you will probably use signal for selector a lot more, particularly UI view controller. And on that note, RAC 2.0 and Objective-C for life. Thank you. Should I ask a question? Wait for the panel. Okay. Thanks, everyone.
Oh, well, I mean, I'm up here now, mate. Yeah, go for it. Why not? We'll have a couple minutes to questions.
Okay.
Why not? Go for it.
So I'm not super familiar with the nitty-gritty. So the disposable thing where you were observing where you're creating a signal for the managed object operation, and then you check to see if disposable button as well. Is that just because the subscriber may have just gone away?
Can you repeat the question?
Yeah. So the question was for the core data disposable. When we checked for, so yeah, the question was, why do we check whether the disposable has been disposed? So a signal, when you create a signal, when you subscribe to a signal, that's one point in time. Later on, inside that perform block, that could be who knows how long later, right? Like, because the manage object context has its own internal queue, and maybe that queue is doing other work. So it might take a while to get to that point. And I didn't cover it here because it's not sort of a good idiom. You could theoretically dispose that signal yourself, right? So you would have had a signal from that, and you could have disposed it yourself. But as I mentioned, you might also be firing off these based on some like fast input, and then you might use switch to latest, which will cancel signals for you. There's other ways that the API can cancel signals for you. Take until is another example, because maybe your view controller gets popped off the stack and it cancels all the work that it's doing. So we don't want to do that core data request because it's not needed anymore. It's been disposed. You can't send any values to the subscriber. Basically, no one's listening anymore.
Can you talk about? Thank you, David Newman, on the ball.
Nice.
Can you talk a bit about why we would want to RACify all these third-party APIs and Apple-provided APIs? what the value is there?
Well, I mean, if you believe Reactive Cocoa is a good thing, then you'll want to use that in as much as you can. I guess if you don't use Reactive Cocoa for all these APIs, then you're just going to be doing more imperative work and more. You're going to have almost two styles of code. You're going to have the code that you write for your own app that you use signals for, but then if you're not using signals for Apple's code, then you're kind of going to be jumping back and forth from two different styles and conceptual sort of paradigms, basically. So, but using those things, then you can start to have basically a lot more declarative code because, again, you're using these same operators that you would have otherwise been using, the delegate methods, etc. I don't know if that answered your question very good. Basically, if you think Reactive Cocoa is good, you'll want to use it as much as you can. That's my experience.
Hi. I'm not super familiar with the framework, but I had a question. So you mentioned that with take until or other functions, the disposal happens automatically. Does that happen even if we get like a completed or an error event?
Yeah. So yes, when you create, in create signal, that's a good question. I didn't ask or bring that up. When you create signal, when that disposable, if a signal errors or completes, that disposable will get called. Okay. So it pretty much will always get called. Either someone explicitly manually disposes, or your signal will eventually lead to it. As I mentioned, there are some signals that don't ever complete. There are infinite signals, so it's possible that it never happens because you've designed a signal to be infinite.
Thank you.
You're welcome. Thank you.